Once again, welcome to the lesson on conservation of energy and momentum. So, in the last classes, we were discussing about the examples of conservation of angular momentum. Today, we will discuss another example for the conservation of angular momentum, which is the shape of galaxy. As you know, galaxies are a group of large number of stars, including gases and void spaces, that is the empty space. So the galaxies are born when these prehistoric clouds of gas, stars and dust particles are collapsing under their own gravitational attraction. Each galaxies are separated from each other by a large distance. Now in the universe, there are different types of galaxies depending on their shape. There are elliptical galaxies, then irregular galaxies are there, and a majority of the galaxies are included in another category called spiral galaxy. And our own galaxy, that is in the Milky Way galaxy, is one of the example for the spiral galaxies. According to the modern observations, about 70% of our nearby galaxies are spiral in shape. So here we will discuss what is the reason for the disc-shaped nature of the galaxies. It can be explained based on the law of conservation of angular momentum. As already mentioned, the galaxies are formed by the gravitational condensation of very large quantities of gases, clouds and dust particles and stars. So we consider a very large mass of clouds, gas and stars in spherical form initially. And suppose this system has acquired some initial angular momentum about any axis. So here this spherical system of particles or clouds or stars has an initial angular momentum along this axis represented by J. So this is the axis of rotation of this system of particles. As there are only mutual forces of attraction, because these particles are condensing or they are contracting under their own gravitational force of interaction. And this gravitational attractive force is an internal force. There is no external force. As this is internal force, the total angular momentum of this system is conserved. Or we can say that the total angular momentum mvr, where m is the mass of the particle and v is the velocity of that particle and r is the distance of the particle from the axis of rotation. So mvr is equal to k. It will be a constant for the whole system. That is, if we calculate the total angular momentum of the whole system by using the formula mvr, then that total angular momentum will be a constant. Now, as the gas contracts, we can say the distance between the gas and the axis of rotation. This is the axis of rotation. So as the gas contracts in this direction, the distance between the axis and that particle will decrease. So r will decrease. As r decreases, because J is conserved, the velocity of the particle will increase. So on an average, we can say that the velocity of the system will increase. So the kinetic energy also increases. Now gravitational force is a conservative force. So the total mechanical energy is also conserved. So the increase in kinetic energy is supplied by the decrease in potential energy. That is, the gravitational potential energy is minus G into mm by R, which is the basic formula. So the increase in potential kinetic energy is supplied by decreasing the gravitational potential energy of the system of gas itself. Now there is another mechanism. The contraction of the gas will result the decrease in the distance r between the particle and the axis of rotation. So that velocity increases, kinetic energy increases, and potential energy decreases. But there is another force that is called the centrifugal force. The centrifugal force is mv square by r. This is m. It is mv square by r, which is acting on a particle of mass m. And the gravitational attractive force between two particles will be gmm by r square. This is m. gm by r square. So that gravitational potential energy, attractive force, when it becomes equal to the centrifugal force, the further contraction is stopped, because the centrifugal force will stop the further contraction of the gas particles. Now the angular momentum remains a constant. So mvr is equal to constant. So velocity v is equal to k by mr, where k is a constant, m is another constant for the particle. So we can see that the centrifugal force is equal to mv square by r, which is equal to m by r into v can be written as k by mr. So k by mr square, we get k square by mr cube. Or k is constant, m is another constant. So this k square by m can be taken as another constant, say capital K. The important point is the centrifugal force acting on the system is equal to k by r cube, or centrifugal force is inversely proportional to the cube root of the distance from the axis of rotation. So as the distance r decreases, the centrifugal force increases very rapidly. So as the decrease in distance r between the particle and the axis of rotation will increase the centrifugal force very rapidly, and that centrifugal force opposes the contraction. Because we can see from this diagram, that is, if the particle contracts under a gravitational attraction in this direction, that is in a direction perpendicular to the axis of rotation, then the distance of the particles from the axis of rotation decreases. So r decreases, but that decrease in r will increase the centrifugal force, and that centrifugal force opposes the contraction. So the system of particles cannot contract under this direction, that is in a direction perpendicular to the axis of rotation, because the contraction of particles in that direction will decrease the angular momentum, which is prevented because the law of conservation of angular momentum says that it is constant. But at the same time, the particle can contract in a direction parallel to the axis of rotation. So that particle can contract in this sense, and also they can contract in this sense also. It is parallel to the axis of contraction, they can contract in both sides towards the center of the system. So what happens? What is the result? The cloud of gases or the stars is able to collapse under the gravitational attraction in a direction parallel to the axis of rotation. Parallel means in both directions, that is parallel and anti-parallel. This is actually anti-parallel and this is actually parallel. The particle contracts in this direction. The distance between the particle and the axis of rotation, that is small r, which remains constant. So there is no change in angular momentum. So the contraction of particles in the direction parallel to the axis of rotation is not prevented by the law of conservation of angular momentum. So what will be the resulting case? You can see that the spherical shape, which is initially which was spherical with a small angular momentum in a particular direction, then because of the conservation of angular momentum, the contraction in a direction perpendicular to the axis is prevented, but the particles can contract in a direction parallel to the axis of rotation. So what happens is, the particle can contract without changing the angular momentum or without violating the law of conservation of angular momentum in a direction parallel to the axis of rotation. So the particle will contract in this direction, and hence the galaxy becomes flattened, because ultimately the particles can contract in this direction, but they cannot contract in a direction perpendicular to that one. So it will be flattened, ultimately appears a convex lens shape, like shape. And we see that in nature, in universe, there are different types of galaxies, and about 70% of them near our Milky Way galaxy, it belongs to the elliptical galaxy, and some about 10% belongs to the 70% belongs to the spiral galaxy. Sorry, 70% of the nearby galaxies belongs to the spiral galaxy, and about 10% belongs to the elliptical galaxies. They are also disc shaped, and about 20% is having irregular shape. And this irregular shaped galaxies, some theories predict, says that it is formed by the collision between two galaxies, and this is a classical approach. The research is going on in the field for the shape of the galaxies, and the disc-shaped galaxies can be explained partly by using the law of conservation of angular momentum. So please try to answer the following questions. What is meant by a galaxy? In which galaxy Earth is situated? And the role of law of conservation of angular momentum in shaping the galaxies. And what are the centrifugal force, then gravitational forces of attraction, then gravitational potential energy, etc. are the key factors in this chapter. So thank you for watching this.